Okay, I think in the last time we are talking about some of the application used for the landslide monitoring, right? Okay, and you can see that we already talked about the underground measurement, especially for the piezometer. Okay. This is the piezometer, and of course, we already talked about the inclinometer. Okay, so next time I bring the real inclinometer and also the ABS pipe. Okay, and we also deliver homework to discuss the behavior of the inclinometer. Okay, and for the service, I think from the right side to the left side, the first one is the extensometer. Okay, to measure the displacement of the surface crack. Okay, this is the what we call the tension crack. Okay, and of course in Taiwan, I think the rainfall is the most important factor of the landslide. So how can we get early warning? I mean, to warn somebody that may be affected by the landslide. Okay, in Taiwan, we have Water and Soil Conservation Bureau, and this bureau take care the lives in the mountain area, especially for the debris flow problem. So for his, I mean, for this period, they claim that if the rainfall, I mean the daily rainfall, for example, more than 300 millimeter per day, okay, then I will give a sign, I mean, to offer the excavation to these people because they try to escape from the debris flow. Okay, we also talk about the settlement gauge, crack meter, and also this is the incline meter or incline gauge for the retaining wall. Okay, I think maybe we can use this. Okay, so I think I just showed the most and the common seed instrument, especially for the landslide monitoring. So everyone can think about it, because in the first part of this class, I already show most the different kind of the transducer or the sensor, okay, like the strain gauge or the vibrating wire sensor. Okay, so you can think about it because right now I think this is very easy to check out the spec and I mean the principle of each sensor, especially for this one. Okay, you can understand how they work. Okay. Okay. So in the last time, we extended to the tunnel instrument instrumentation. Okay, and I think in the last time we already showed that if you try to monitoring, I mean the shape of this tunnel. Okay, and you may need some of the rock displacement transducer. Okay, and also sometimes if you use the rock bolt, maybe you need a low cell to understand the pressure. Okay, and also we have some of the micro creep meter to make sure that your shape or the geometry of this tunnel keep constant. Okay, and I already showed that there's a very unique what we call a basalt convergence systems. It's just like the inclinometer, but in a different type. You can see this is the short arm, longer arm, short arm, longer arm, short, long. Okay, each arm have their own, I mean the tilt meter, So maybe next you can find here. Oops. You can find here. This is the real picture. Okay, so you can measure the incline degree. I mean that you can also measure the theta, maybe between the gravity direction to the incline direction. Okay. So this is just like the inclinometer. If you already have a fixed end, so you can calculate the shape of each basal convergence systems. Okay, so I think this is very unique, especially for the tunnel monitoring. Okay. And the next, I would like to show you the very important infrastructure in the geotech area. This is the dam. Depends on the shape of the dam, we can divide it into several types. The first one, most common to see, it is what we call the embankment or the gravity dam. Okay, and the next is arc dam, and this is a different kind of the shape, and the other is buttress dams. Okay, so we will talk about what it is. For the embankment, or sometimes we call this is the earth dam. So you can see this is the material. Best material is soil, right? And using the compaction, we can build a very dense and very strong embankment for the water storage or the river bank. Okay, and then the other one is what we call the gravity dam. I think two of these is using a very large material, and it depends on the owned gravity to defend the water pressure. But the first one is made by soil, and the second one, this one, is made by the concrete. Maybe I think I can turn off the light. Okay, the second one is made by the concrete. Okay, so here you can find actually this is the what we call the bigger size retaining wall. Okay, so later I will show you how to evaluate the stability, okay, of this gravity dam. And the third one is arch dam. So if you have, I mean, the top view of this octane, okay, sometimes will be like this one. Okay, so this is the upstream, and this is the downstream. Okay, so from your maybe the basics of the mechanism, so you will understand if I have the lateral water pressure from the upstream. So how can we transmit the pressure in this kind of the arc dam? You can see here, maybe I just replot again. Okay, so the pressure, water pressure from upstream will transmit to the what we call the embankment. The pressure will transfer to the two sides of what we call the embankment. Okay, and so the stability of this embankment will be very important. Okay, and the last one is the batteries. I think this is most likely the gravity dam, but with a little bit different of the shape. Okay, so I think this is the most kind types of the dam. And here, this is the different side view from the section view to the top view, plan view. So I just show you on the arc dam here. Okay, this is the upstream, downstream. So we will transfer the pressure to the embankment. Okay. So here I have some very quick video to show you the earth dam. And this video shows the potential failure modes of the earth dam. I think in the last time I already showed that actually we will have an underground level here, the yellow line. This is the water pass underground. This is often noted by seepage exiting on the downstream face of the dam. Weak or poorly compacted soils can increase both seepage and the phreatic level, as well as weaken the embankment, contributing to a sliding failure of the dam. As a filter to keep seepage from moving any soil, as well as allowing seepage to be removed in a controlled fashion. This lowers the phreatic line and improves the stability of the embankment. For existing dams with a high phreatic line, two alternatives can improve the dam stability. One is to add a drain near the toe to both filter the seepage and lower the phreatic line. So this shows that how to decrease the level of the underground. For added resistance and improved stability of the embankment. This does not lower the phreatic line, but improves the dam stability by adding weight to prevent slide in the embankment. Okay, I think this video showed that the big problem of the typical earth dam, I said this is made of the soil, right? So actually, we cannot prevent the water flow. Actually, we cannot. We just slow down the velocity of the water flow. Okay, so actually we have the underground water level and what it is the pass. So we trying to decrease the velocity. So sometimes one strategy is that using like this is the maybe the concrete, maybe of the concrete. Sorry. Okay, and try to stop and extend the path of the water flow. And then the other way is that we can use, in the last time, I already showed that maybe we can use the different material as the core. Okay, so sometimes we use the very fine, like the clay or silt, because in the geotech, we call this is the permittivity or I don't know how to say that. 水力传导系数 hydroconductivity constant. Okay, it is what we call the K. It means that inside of this fine material, the velocity of the water flow is very slow. It's maybe only few millimeters, maybe per day or even per month. The water flow very slow. So with this kind of the core, you can see the water level will have a great decrease between this area. So this is another choice, another strategy to slow down the water flow pace inside of the earth stem. Okay, so I think, oops. And this video also shows some advanced technology to maybe lower down the water level in the toe of this earth stem to increase some of the drainage paths. Okay, and the other strategy is try to increase the volume of this earth stem. Of course, increase the weight and increase the stability of this slope. Okay, so I would like to say, based on this idea of the possible or the potential failure mechanism, and then I would like to say, if you are an engineer, if you have already assigned a task to build this kind of the earth stem or embankment, what kind of the sensor you may put inside or outside of this earth stem, and where you can put, because you have a limit budget. You cannot put the sensors in every location. It is impossible. So you need to find some place that has a higher potential of failure, right? Okay, so I think this will be the main concept for the monitoring in this class. So this is I think this is the example to show the typical sensors and the typical area or location we're trying to put in the earth stem. So I think maybe it is not so easy to see, but you can find in your lecture. Okay, so I think I would like to show you the first one is the piezometer. Piezometer number 6. Okay, so this is the piezometer. Piezometer. Okay, sometimes maybe we can put the inside of this area. So just I say, why we need this kind of the piezometer? Because we trying to understand, for this is the core. Okay, so for the water level, they will be like this one. This is the underground water level. Okay, so if it also depends on your level of the storage of the water, but for the maximum, I mean for the highest water level, okay, so I think we need to make sure that the underground water level should not show on the downstream, the slope on the surface of the downstream. Okay, so if the water level is too high, then we may have some seepage here. This is not so good. Okay, it is not so good for the safety of the earth dam. So we trying to monitoring the water level to make sure that the water pass should be in the right elevation. Okay, so this is we can measure the water pressure in a different location. And later of this class, I think we may have some of the data interpretation to make sure that your monitoring result is good or not. Okay, so this is the piezometer for the first. Okay, I already show you a very important potential failure mode of the earth dam. Can you give me maybe another potential failure mode for this kind of the earth dam? I mean that overtopping, yes. Okay, this is the second one. We need to make sure that the water level never higher than the top of the earth dam. Why? Because just as I said, it's made by the soil, compact soil. But if you have the overtopping, means that this flow, just like the rainfall, okay, and will destroy the surface of this the earth dam. And this is what we call the erosion. Erosion, surface erosion. Okay, so they will decrease the stability of this earth dam. So, of course, sometimes we need to put a sensor to monitoring the water level. Okay, and for some of the maybe the environmental or the hydrological experts, they also try to predict. I mean the inflow of the reservoir, because they try to predict how many volume of the water need to be maybe flush out for the better capacity of the water storage. Okay, so this is might be the second possible failure mode for the earth dam. Any else? Third one? Can you image why this earth dam will fail? The first one is because of the seepage of this water flow. The second one may be the overtopping. Okay, and what is the third one? If you already or you are charged to the build this kind of the earth dam. Any idea? No idea. Okay, let me give you a very quick sign of this. Okay, there's a hint. Sometimes we may install the strain gauge or the settlement sensor inside of this earth stem, and sometimes we will monitoring the surface elevation of this earth stem because of what? Why? I just said that the earth stem is made by the soil with the compaction. You know, like the compaction, right? Get a higher density of the soil. But however, inside of this, still the clay, the materials still a clay was sealed because we try to slow down the water flow velocity. But this kind of the soil have some problem. What is the problem with that? Consolidation problem. Okay, with the time, the layer of this soil clay was sealed. I mean, the volume will keep concentrate. I mean, the consolidation is mean that we may have the settlement of the surface. So, of course, for this kind of the earth stem, the consolidation problem cannot be prevented because with the time, this stem maybe have some of the problem due to the consolidation. But somehow, for the experience, if this is just only maybe the 100% of the height, it is okay. But over than that, maybe the settlement, I mean the settlement of this earth stem have a big problem because in the last time, 21 years ago, we have earthquake, GG earthquake, the biggest one in this century. Okay, one of the earth stem have a big, I mean, the movement. So the elevation change a lot. So we need to focus on this kind of the value of the earth stem. Okay. So this is another choice for the sensor configuration. So here you can find this is also the pore water pressure, and also you can use for the level of the underground. Okay, and this is for the settlement. You can measure the settlement in the different depths of the location. Of course, you may have the soil pressure gauge to understand actually the earth's pressure in a different location. But I would like to say right now, this kind of the earth pressure, it is not so easy to get a very long survival time. Okay, because construction. Okay. But I just mentioned the earth stem, and the next I would like to show you the gravity or the concrete dam. Okay, so this is the typical picture of the gravity dam or earth dam. This is the spillway, and this is maybe the hydropower plant using the hydro gradient, different hydro gradient to generate the electricity. Okay, and this is the main spillway. Okay, this is downstream, this is upstream. I would like to say, do you know how to tell from the right side of the river and the left side of the river?
Downstream?
Yes, depends. If you look the downstream direction, so the right side is mean the river right side, and the left side is the river left side. Okay, So in the right side, this is the right side, and this is the left side of the riverbed. Okay, and sometimes we may have the water intake. Okay, depends on the design. This is the maybe the well or tower to bring the water to the maybe the some of the clean water cleaned plant for the drinking water supplied. Okay, and of course, for this kind of the concrete dam. Okay, next, this is the profile of the concrete dam. Sometimes there may be like this one. This is the for the inlet for the hydropower generation. Okay, so based on your maybe the lesson in the school, what kind of the failure mode can be for this kind of the concrete dam or the gravity dam?
Liquefaction.
Liquefaction, you mean the stability of the foundation? Okay, that will be a good point, a viewpoint. But somehow, before you try to build a concrete dam, I mean that this is a very important infrastructure. The investigation of the geological condition regionally is very important. So sometimes we need to find a very good place without maybe like the liquefaction, yeah, or maybe the foundation with the very low strength or shear strength or the bearing capacity. We need to exclude this kind of the geological condition. But I would like to say in Taiwan, it is very hard to find a very good quality place because you know that in Taiwan we have young geological conditions, or also the many fault and an earthquake. But this is a good point. We need to confirm the stability of this foundation. So yes, there will be a good questions for the how can you make sure that the foundation of this earth dam is stable or not? Okay, because this is the gravity dam. We use this own gravity to prevent the water pressure. Okay, so I may give you a hint. This kind of the concrete dam, like the retaining wall. So from your class, maybe there is a three indexes. We need to make sure the stability of the retaining wall. Okay, the first one is the bearing capacity, right? We need to make sure that. So sometimes we need to maybe check the water pressure here, and also some of the measurement here. You can find, let me see here, 12. This is the earth pressure cell in this area. Okay, and also in this area. And this makes sure that the pressure maybe lower than the ultimate bearing capacity of this foundation. Okay, and what is the second one? If you already build this kind of the concrete dam, how can we defend the water pressure? How can we? Okay, I would like to say, if you have a concrete dam and you have a water pressure, so I need to make sure that this concrete dam cannot be moved laterally. So one thing is that we need to make sure that there's no more movement laterally. Okay, and the third one is because we have a moment, so we need to make sure that there is no more rotation of this concrete dam. Okay, so based on these three, I mean the principle of this concrete dam. So how can we monitoring? How can we put the right sensor in the right place? Okay, for this one, rotation. Here, this is the pendulum here. To measure the rotation degrees of this concrete dam. Okay, and the second one. Okay, so this is the idea of the pendulum. Okay, also measure the inclined degree between the gravity direction. Okay, of course you can put some of these the tilt meter in a different location here. Okay, and for the stability of this concrete dam, sometimes there is another very important measurement is because you know that for this kind of the concrete dam, it is made of the block by block, right? So every block maybe have an interface. So sometimes we need maybe a extensometer or the crack meter to measure the interface of these concrete blocks. Okay, and I would like to say this is a temperature gauge. Where? Here. Why we need a temperature gauge inside of this concrete dam? Why? Can you?
The expansion of the material, the temperature, if it's too hot,
Yeah.
it will grow, and then if it's cold, lower, and then can create cracks in the concrete.
Yeah. This is I think the main reason. Okay, and this is the main reason, and the second reason is that because during the construction of this concrete dam, because you need to put the concrete and have the block. Sometimes it takes time because there's a heat need to dissipate with the time. You know that the Hoover Dam in America, this is maybe the largest, one of the largest the concrete dam in the world. For some rumor, they say that there's still inside of this the Hoover Dam inside because the fallen is too huge. So inside of this Hoover Dam, the temperature of this concrete still high, very high. Okay, and in Taiwan, I think we have several concrete dam made by the Thai Power company. Okay, they use this kind of the reservoir to have hydropower generation. But if you have a time, you can visit this Thai Power reservoir with the concrete dam. The next, you can find some of the ice cream store because in a period of the construction time, they the Thai Power company buy so many, I mean the ice machine to cool down the temperature of the concrete. Okay, so after the finish of this construction, the transfer to of this ice machine to make the ice cream. Okay, I think in northern Taiwan, the central Taiwan, the southern Taiwan, and also the eastern Taiwan, have the ice cream store nearby the Thai Power concrete dam. Okay, maybe next time I can bring you to buy the ice cream. Okay, where will be maybe okay maybe in the next month, depends on the decision, right? Okay. Okay. Okay, I think this is another profile for you to understand. This is the block, just as I say, of the concrete block of the concrete. Okay, so the interface between the concrete blocks, maybe we need a joint meter or the extensometer. Okay, and of course, the thermocouple or the thermometer will put on the surface or inside of the concrete dam to make sure that maybe some of the expansion of the very hot weather. Okay, and this is the gravity dam. This is the arc dam. Okay, and the third one is the arc dam here. So for this kind of the arc dam, the most important that is you need to make sure that the stability of the two sides. Okay, because this is the main, I mean the concentration of the stress to prevent the water pressure upstream. And this is the, okay, I don't know, I already showed that before in the beginning of this class, is the Oroville Dam in maybe California. The second second highest dam in the US. Okay, so in the 2018, this is the Earth Dam in this area, and this is the spillway made by the concrete in the surface. But somehow in the 2018, just you said, they have a very big rainfall event, and for that time, they use the spillway to try to decrease the water level because there's too much rainfall upstream in the watershed area. So the water level keeps increasing and maybe have the problem of the overtopping. So they're trying to enlarge the water flow by the spillway. But somehow you can find here, there's a problem because like I mean, from the finish of this construction till now, the spillway is less used before. So I mean that when you try to use the spillway to enlarge the flow to decrease the water level of the reservoir, but unfortunately, there's a big landslide in this area. Okay, maybe I later I can show you the detail. This means that if I keep continue of the flushing by the spillway, maybe this area have a big landslide, and maybe they will lead a big problem of the dam breach in this area. Okay, so maybe this is the first emergency of this earth dam. So they need to find a second solution to decrease the water level of this reservoir. So they try to use this area for the natural overtopping, like the spillway. But somehow they find that it is impossible because there's a very great erosion, soil erosion during the overtopping. So maybe I can find you the main Okay, sorry. Let me show you the. Okay. I think the Oroville Dam located in close to the oh, oops. Close to the Sacramento, okay, Sacramento city here, Sacramento city, okay. It's a NBA team, Kings, all right. I'm so sorry because there's no more NBA play anymore. Okay, and then this is the San Francisco, okay. So this is the location of the Oroville Dam, and this is the aerial photo. So this is the dam site, and this is the spillway. Just I show you. Okay, so you can find this is a very big dam, and of course, in the downstream, there's this is the Oroville downtown, and this is the picture. Maybe I found from the Google Earth Pro. So I think Google Earth Pro is a very good tool if you try to have some quick image before you have a plan. So this is the dam, Earth Dam, spillway. And just I said, this is emergency spillway using the natural overtopping. Okay. So here, because just I said, this is the landslide, a very big hole. So they try to trigger the emergency spillway. And then this is the picture here. Very, very big hole. Maybe you don't think, but after that, let me show you. Maybe there's a 1 people high in this spillway. Means that this spillway is very, very huge. Okay. So maybe I have some of a video for you. Okay. Okay, and this is inundation map. I mean, this is the dam site, and the red area is the predict the inundation or the flooding area. They predict. So in that time, I think maybe 200,000 people already assigned or have a warn for the escape from this area. Okay. So if I need to ask the same question again, if you are an engineer, how can you prevent this kind of the issue? I mean the dam breach. Okay, and I think here I have some video for you. Maybe this one. So this is the after the 2018 they tried to rebuild. So you can find this is a very huge and very large spillway. Okay, the main surface is the rock. Okay, so they trying to rebuild the surface concrete again. And this is using the drone UAV to take this kind of the picture during the construction. Before, so this is the original, the big hole, just as I said, the big hole, and then this is the after. Okay, this is the after image. Okay, and this is another show. Of course, I think we need because I think in my here. Oops. Oh, I'm so sorry. Maybe we can have a 5-minute break because I think originally this is the video. Let me check how to play this video.